So today we're going to talk about exponential decay. Go ahead and take a few moments, set up your notes, exponential functions, homework 4A, Unit 4A, homework 5 with the appropriate date, and also remember to set up for questions and comments on the right-hand side of your paper. Go ahead and pause and do so now before continuing on. So radon is a naturally occurring radioactive gas. It was identified as a health hazard in some homes in the mid-1980s. Since radon is colorless and odorless, it is important to be aware of the concentration of the gas. Radon has a half-life of approximately 4 days. Now, if you haven't heard of half-life before, this is the time that's required for exactly half of the amount to decay on average. So Tony's grandparents' house was discovered to have radon concentration of 400 psi per liter. Renee, a chemist, isolated and eliminated the source of the gas. She then wanted to know the quantity of radon in the house in the days following so that she could determine when the house would be safe again. So the first thing we want to do is we want the amount of the radon in the house 4 days after the source was eliminated. You should be able to explain your reasoning. Now keep in mind, we're starting with 400 psi per liter. So if we know that every 4 days, that's the half-life, this 400 should cut in half on average. And that would leave us with 200 psi per liter. Once again, every 4 days, it should cut in half. That's the meaning of half-life. So compute the difference in the amount of radon from day 0 to day 4. So the difference would be from 400 to 200. We want to subtract. And that gives us a difference of 200. Now ratio is the amount of radon on day 4, which was 200, to the amount of radon on day 0, which was 400. So we want to set up a ratio or a fraction. So we have 200 as a ratio to 400, which gives us 1/2. Let's go ahead and take a moment, pause, copy, before we continue on and see what to do with these numbers. So now I've kind of got a feel for how this is going to play out. I should be able to complete the table for the radon concentration in the house as the days continue. So we set up a table. We have half-lives. Once again, one half-life is 4 days. And at the end of 4 days, we know that we went from 400 to 200. And then we were able to find the difference between the concentration of consecutive half-lives, which was 200, and then the ratio of 200 to 400 was 1/2. Now, we could continue on with the same pattern if we go to day 2. So day 2, the next half-life would be 4 days later, which is day 8. It went half of 200 is 100. Once again, the difference between 200 and 100 is 100. And then we go ahead and do 100 over 200 as a ratio. Gives me 1/2. Half-life of 3 would be 4 days after after 8, which would be 12. And so half of 100 would be 50. Once again, the difference between the two is 50. And then we do a ratio of 50 to 100, which gives me 1/2. And so we see that our ratio of concentration is showing me that this is decaying at a set rate, 1/2. So go ahead, take a moment, write down the patterns you recognize in the table that we just discussed. We'll compare answers in class when you come next. Go ahead and take a moment, pause, and write down the patterns. So now I can go ahead and graph the data from our table on the previous page as ordered pairs. Once again, I'm setting up the half-lives, the number of half-lives, and the concentration. I'm going to connect my points, and once again, I'm going to notice that definitive curve that we've been paying attention to. Now, this one's a little different. If you remember back to the previous day's notes, our curve was going up. We notice that this one is going in a downward curve. So we could talk about domain and range again, and we just have to know that our time has got to be greater than 0. Once again, we can't have negative time, so we're just going to say time is greater than or equal to 0. And then we could talk about the concentration. We know that we started at 400, and then we're going to go down to 0. You're not going to have a negative concentration. So our concentration can be anything less than or equal to 400 or greater than or equal to 0. Now, Renee needs to know the concentration of radon in the house after 20 days. So what I'd like you to do is use the table on the previous page with the patterns you recognized and this graph. Tell me how many radon half-lives are in 20 days. What is the concentration after 20 days? So I know 20 days is 5 half-lives. Once again, the half-life of radon is 4 days. So if I go out to 20 days, that's 5 half-lives. And that's going to give me a CPI per liter of 12.5. Once again, if you just keep halving it every time you go down, you end up with 12.5. Now, based on this, you should be able to tell me how many radon half-lives are in 22 days and predict the concentration after 22 days. Now you notice I'm going from 20 to 22. I didn't make it a full 4 days. I only made it half of that. So it's not going to go from 5 to 6. It'll go from 5 to 5.5 half-lives or 5.5 half-lives. Now that means we're not going to do half of this. We're only going to do half of the half. So if I go down half of this and then add half of it back, I get 9.375 PCI per liter. Go ahead and take a moment, pause, copy before continuing on. So what you noticed about the decrease in the radon concentration in Tony's grandparents' house is an example of exponential decay. And this can still be modeled using an exponential function. We still have our f of x equals a times b to the x power, where a is our constant factor, which is also known as the initial amount that we're starting with, which in this case was 400. B is going to be our decay factor, the rate at which it's decaying on a constant. And what makes decay different from growth is that decay has got to be less than 1 but greater than 0. So it's going to be a positive number, but it's going to be a decimal or a fraction. It's going to be less than 1 but greater than 0. So we look back at our table and we notice the constant rate of decay was 1/2. So our B would be 1/2, our A would be 400. So here we have the try it out section. I'd like you to go ahead and try out this part, answering these 4 questions. Once again, the answers will be on the next page, so please go ahead and pause now, copy, and try this out before looking at the answers. When you come to class next, make sure you bring any questions, and we'll go over these answers in class. Good luck, and I'll see you next class.